Hey, welcome back to Engineers Workshop. In case you're just joining us, we're working on these parts right here, which are axle spacers for project car 1972 Spitfire that's getting a Datsun 510 rear differential and new powertrain altogether. So this is part 3 of machining these. We just started out with scrap pieces of steel 4¼ inch OD. We've got them flat. We've got locating features for both the axle stubs and the differential flanges, output flanges. And now we're moving on to, we got to do the machine the OD, put chamfers on the edges, and a bunch of holes to locate. It's the first time I've used the K&T rotary head mill for hole drilling, and let me tell you, it just does an awesome job. So this is primarily a lathe part, but we don't have a lathe, so we did the entire thing on the rotary head mill. So make sure you watch the whole video, because I mean, there's some really cool slow motion shots I've done of the hole drilling. And then once we wrap that up, that'll be part 3, and then part 4, the final installment, we'll be doing all of the counterbores. We've got counterbores on both sides of this to recess the mounting studs and the attachment bolt head. So right over to the machining now. Let's go. For the next operation, I've gone back to clamping both of these parts in the center. They are to their finished thickness of 3/4 inch. And now we will get to bring the ODs, which is a rough 4 1/4, down to 4 inches. It's not a working surface, it's just clearance. But I'll try to get it reasonably close to 4 inches in a few passes. Once it cleans up fully, I'll check progress and with the calipers, and then make adjustments as necessary. Come down until I just start to make chips on the aluminum. That way we know we're fully machining the full side of the part. And we'll give it another 5/1000 for good measure. Come in until we're close, and I will bring it in as the head is rotating. I also decrease the RPM of the head to 1/2 RPM. No guarantees. This was 100% concentric, so it may skip around, missing some of the OD, but we'll keep bringing it in until we get a full cleanup. Four inches 182, so we have 182 thousandths to come off. Now it's a 50 thousandths cut. Now about 45 thousandths oversize. So I'm going to switch and conventional mill this, because I am getting a little judder in the rotary axis, which I think is contributing to that washboard, even though you can't really feel it. And so I need to take 22 thousandths off per side. And 21.5 thousandths, and we'll call this a finished cut. We'll go around one more time for a spring pass. You can see there's a tiny bit of aluminum picking up onto the steel. .996, tiny bit under. Not a big deal, it's just clearance. .4035. About 17 thousandths off the radius. There's 15 thousandths. We'll see what this does. Looks like we overshot the last one by a hair. .410, enough room for a 5 thousandths cleanup cut. Thousandths over. I'll take it. Next operation I want to do is not on the print, but I want to put a little chamfer on both of the OD outer edges here to break that sharp edge, and it just makes for a much nicer looking finished part. So if you're wondering why I'm flipping this over, it's because I have just freshly machined the OD of this, and I have a matching witness line on the aluminum, so I can pretty much flip this part over and get it exactly centered, matching up that witness line to where I can get the exact same look all the way around with a minimum of indicating, and I'll still be concentric. I traded out the 4-flute end mill for a 2-flute mill that has a 45-degree chamfering end on it, and I'm going to put a 30 thousandths chamfer on both of the outer edges. Right now those edges are sharp enough to cut you, so I'm going to take that off. Let's do 30 thousandths actually. Come down until we touch, and then dial in an additional 30, and just walk that around. And incidentally, I did flip this over, so now the projection is up, and I located this by indicating the OD concentric to this location. This is location 2, location 1. Looks a lot nicer than that. Next series of operations is pretty straightforward. We've got a total of 16 holes that we've got to put in over the two pieces. I'm going to start with everything that's on the x-axis first, and we're just going to hit every hole location on these views. First with a center drill, then with a pilot drill, and I'm going to keep the pilot drill at 3/16, same size as the center drill I have. Then we will take them, I got two drills from McMaster Carr. One I believe is on size, and the other one I'm going to have to walk it out, that one right there, and get this press fit exact for these studs. But we'll have all of the holes put in from one side, so we won't have to move these pieces. And then we can proceed directly into doing these counter bores here with the rotary head. These will require a different setup, and that'll be in the last video. So let's get back over there and start machining. First hole is at minus 1.498, and these four will be all on the x-axis. I thought that was happening. Now none of these patterns are like a 90, you know, 4 equally spaced, so we're off 0.265 this one, and the Y is 1.474. Now 5.265. Since these all belong to the same feature, I'm going to color these black. The next set of holes is also on a rectangular pattern, but I've got it oriented parallel to the x-axis, so I just need one Y offset on either side of 0, and then 4 X locations to locate those. Minus 1.312 for the first location. Y is 0.949. Just broke my center. Doggone it. I don't care much about the broken center, but the part that's still in there is going to be an issue. Well, I haven't had an opportunity to show it much, but the machine does have you know, power feed, quill feed. So we've got an up-down control, and we've got 4 speed ranges and a low and a high on this. Out is the high range. I'm sorry, out is the low range. So you can start your position where you want. We're picking A. In is 1.6 thousandths per revolution. We'll give you an idea of what that does before we actually give it a try. You can see that's feeding down. I want to go conservative with this 3/16 bit. So we'll see how we do. We'll interrupt the feed as necessary to break the chip. I want to mention that I have the quill travel set that it can't go beyond just getting into the aluminum. That's hole number 1. You can really feel when it gets into that aluminum. Now we got to take care of this one. I think I'm going to take a solid carbide 3/8 end mill that's got, it's really got a little bit of damage on the outer edge, but if I take it just a hair off center and plunge it through that piece, hoping to just cut cut the center right off inside the steel. See how it goes. Okay, so I'm going to try to wipe out that broken off center drill with a solid carbide 3/8 4 fluid end mill, and my hole center is 30 thousandths off center. That's as far as I can go and not create a scallop on the surface. In other words, my finished drill size will wipe this this overcut out. So I'm just gonna plunge down in here and see if I can eliminate the center drill, broken off piece, and then I will respot it with a new center drill. It's still in there. I think it just rolled over. Nope, it's gone. I'm going to just come through and plunge down so that I've got a 3/8 diameter that's on location, down to the same depth. One 100, 200, 300, 400. At 400 thousandths deep, which is a little over halfway, I stop it, clear the chips, give it another squirt of goo, then I resume. $500, 600, 750. So that's 750 thousandths full thickness of the adapters. Okay, next we'll be concentrating on the holes colored blue, and we've got an exact drill size for those, 0.4375, so we can take those through and those will be finished. Those are just clearance holes, no need to get those exact, but from my experience with this mill, you know, when it drills a hole, it's on size. It's really not oversized at all. It's a darn good drill press. Switching over to a different collet with a 3/8 chuck capacity here for this 7/16 drill. We're going to take all of these holes marked in black up to the finished size of 7/16. And I've got a makeshift drill bushing here. I'm going to clamp on top of that to guide into that counterbore, because that's one where we broke the pilot drill off. So hopefully that'll keep that one drilling straight. Well, the suggested feed and speed for a 7/16 drill, in my experience, is scary. They're looking at like 7 thousandths per revolution. I am not going to try that. I'm going a little bit slower, 4.7. I've got my depth set so that I will only get into the aluminum and then it bottoms out. And I reduced the RPM to about 700. So let's see what happens. We're going to trust all our numbers. Wow, that's some serious metal removal. One of those drill shavings is going to whip around and hit my camera, I bet. Okay, I have my DRO set for the coordinates of this last hole. So I'm going to engage the drill in this fixture, makeshift fixture, and I'm going to clamp this down in this location. Just to give that drill an extra bit of support, because I had to spot face until I got past the broken off point of the pilot drill, but then the spot face diameter is not as big as this. I'm afraid of this drill pulling off center into the spot face. So this should keep it cutting straight just until it starts to touch that pilot hole. If I did all my calculations right, this drill diameter should wipe out all traces of the off-center counterbore. I need to switch over to an even bigger drill, 33/64 for these holes. This is the closest size I could come to the finished diameter of this that will allow me to put a 1/2 inch end mill down there, walk it out. Those got to be exactly 0.519 for a press fit stud. So I'm going to keep the same speed and feed for this guy. It seemed pretty reasonable for that. So With a 1/2-inch shank, this guy can load directly into the larger collets. Resetting the depth so I just enter the aluminum. We'll do all the holes on the x-axis first. Okay, I slowed the RPM down to about 650, which is what was recommended for a 33/64 drill. And this is draining because this hole goes all the way through. So here we go. To measure these holes, the ones that I just finished here with the 33/64 drill bit, those are a little bit undersized. I've got this nice set of Brown & Sharp, I think it's 672. Yeah, Brown & Sharp 672 set of parallel measuring gauges and a little chart here. And you basically select the two parallels that will correctly measure the size hole that you're working with. In my case, it's a B and a D. Then these go together, and as they slide in and out, they increase their width. They've got a cylindrical OD, and then you can accurately measure the hole with a pair of micrometers, not have to fool around with pin gauges. So once those are in the hole, just take your conventional mics, 0 to 1 inch, at 514 to 515. These only have to go up to 519, so it's not very much that they have to be opened up. And to do that, we're going to put the 1/2-inch end mill in, center up on each hole, and then do a very small 1/1000 oscillation of the head, of the rotary head. For a 1/2-inch end mill to make a 0.518 hole only requires a 9/1000 orbit. So we're going to plunge down into the center of this hole. I'm going to dial in this orbit as I'm rotating. There's 5/1000. And there's our full 9/1000. Looks like we're 1/1000 shy. I'm right at 0.517 and about 3/10. So I'm going to stop there. I don't want to overshoot it and have these pressed in studs be loose. So now it's a matter of just repeating this same orbit on the other hole locations. I'll spot check a couple of those as we go. I have 18 on the money. Well, I hope you enjoyed that. I just loving the capabilities of this rotary head mill, and it makes a good jig borer too, with the ability to power feed with the quill and have accurate locations on your holes. It is just the cleanest hole making machine I've seen. So we'll finish up on part 4. We got to change the setup from the original 2-position fixture. And then on to other projects that will augment the tool holding capabilities of the K&T. I'm going to do an adapter collet holder for an ER40 collet chuck, and I've got other things I want to do with the mill and projects for this shop. So thanks again for watching. Thanks for all the subscriptions. Till then, stay safe.